There are numerous medical devices which are inside the human body which have to be battery powered. Medical costs are really high, and pacemaker dependent people have to have the operation every 7 years. If the initial patient is 2 years old, that's perhaps 10 times during their lifetime they have to have open heart surgery, which is expensive, not to mention painful. And that could completely stop. So what we've done here is to create a device which harvests energy inside the body and can be used to run the pacemaker instead of relying on battery replacements, which occur every 7 to 10 years. This will greatly reduce the number of operations for people with pacemaker problems. So potentially, one would only need one pacemaker operation, the insertion of the initial pacemaker. And if everything worked fine, that would be it for the rest of their life. The heart beats. It actually beats quite violently, as we've been able to see through surgeries. This beating creates vibration inside the chest cavity. And so we're able to take those vibrations, use a clever device made of piezoelectric material and magnets to capture that vibration and transduce it into electrical energy. And this then can power the pacemaker. So the Air Force didn't actually sponsor this, but it was a spin-off of Air Force-sponsored research to power wireless sensors in aircraft wings. This then led us to this other application of the technology in the medical profession, which is kind of an interesting thing where aerospace engineering can help out the medical profession. In collaboration with Dr. David Bradley of the Mott Children's Hospital, what we've done is we've looked at goats and pig hearts and measured the vibrations in those cavities. And now we have a small grant through the medical school to make some measurements in open heart surgery on scheduled surgeries on people so that we can get the data we need in order to design the device properly. And so we're hoping that this will start some research into powering those devices without batteries, because all of them have to be replaced eventually. Not to mention that batteries are pretty nasty devices to stick inside the human body, and the harvesting materials are a little bit more benign. So it's also safer from that point of view. Aerospace research in this department is vast. There are 25 faculty members, hopefully soon to be 27. We each have 3 or 4 different research projects going on. The heart-related pacemaker business is just one of perhaps 100 different exciting projects here in the aerospace department.